Hi everybody, it's Mrs. Pound, and I'm back with another video from Chapter 3 on Measurements in Chemistry from BJU Chemistry 5th edition. Today we're going to finish Section 3.1 on unit conversion. So our objectives today, we have just one objective, converting between metric units. So today's topic is unit conversion. It's a mathematical process used to change units. In math class, you have done bridge notation. That's basically what we're going to do today for unit conversion. You might also, when you go to college, if you take a science class, it might be called dimensional analysis. So that is the process we are going to use. They're both the same, they're just written slightly differently. I'm going to use more of a dimensional analysis approach because it's easier for me to type on the slides, but I'll show you how it's just the same as bridge analysis. And when we do unit conversion, we use conversion factors. This is a fraction that contains both the original unit and its equivalent value in a new unit, always equal to 1. Because remember, in math, we can multiply things all the time. We can convert and everything. As long as we're just multiplying it really by an equivalent of 1, we can do all kinds of things. So a simple question you might get for unit conversion is, what does 45.5 kilograms equal in grams? So for any of these types of problems, the first thing we do is we write down the original unit, which is in the problem, 45.5 kilograms. And then I think to myself, well, how many grams are in a kilogram? I know that. And so I know that there are 1,000 grams in a kilogram. And when I set this up, I have to make sure that kilograms is on the bottom so that these units will cancel. Okay, that is key. If I know my conversion factor that 1,000 grams is equal to 1 kilogram, it has to be on the bottom. The same unit that I want to get rid of, the unit I want to get rid of has to be on the bottom so they cancel out. Just like when you're canceling out things in equations in math class, remember you have to have like x on the top and x on the bottom in order to cancel them out because then they're equal to 1. Okay, so that's what we're doing here because we know that 1,000 grams is the exact same amount as 1 kilogram. So it's a 1-to-1 ratio technically. Okay, so we're just multiplying by 1. Now, in bridge notation, you would have a line here and a line here. So that's the only difference really between this and the bridge notation, that if you want to use that instead of the x's here, you can put a line down and a line completely across. That's the only difference. Now, at this point, I've gone from kilograms to grams that I want to be in. I'm in grams. So I can go ahead and just do my math. And all the numbers on the top, I multiply together. There's a 1 on the bottom, so I don't even really have to divide. So 45.5 times 1,000 is 45,500 grams. So I have my answer. So this is a really simple problem because there is only one conversion factor here. Okay, so that is the simplest kind of problem you're going to have. So let's do something a little more complex. Let's convert 638 millimeters to centimeters. So again, I start with the quantity I'm given, 638 millimeters. And I think, okay, do I know how many millimeters are in a centimeter? And I might, but let's pretend I don't, because I want to go a little more complex here. I want to make a little more complex problem. I want multiple conversion factors. So let's say I don't know how many millimeters are in a centimeter, but I know how many millimeters are in a meter. And I know that there are 1,000 millimeters in a meter because millennium, 1,000. So I plug that in, I put that down, I make sure millimeters are on the bottom so it cancels out, just like when I'm canceling out variables in math. And I have meters on the top. I'm not quite there yet because I want to get to centimeters, but I know how many centimeters are in a meter. Centi, century, 100 centimeters are in a meter. So I add that on and I make sure that my M's cross out. So I put my meters on the bottom and my 100 centimeters on the top so that these cancel out just like in math with variables. Okay, I can't cancel it out unless I have one on the top and one on the bottom. And at this point, I'm in centimeters, so I can stop and I can plug this into my calculator. I multiply across the top and then divide by what's on the bottom, and I get 63.8 centimeters. You could also cancel out some zeros here and realize that you're just dividing 638 by 10 too. Okay, so that was a little more complex, two conversion factors. Let's get even a little more complex. Now here, I want to go from kilometers per hour to meters per second. And so I have to change my kilometers and my time. Oh, well, do one thing at a time. Don't try to get too complex here. We're going to do one thing at a time. And the very first step is I write what I start out with here, 65 kilometers over 1 hour, because per means divide by an hour. Okay, so I just divide, or excuse me, I just write down what I'm given. Now I'm going to focus on the kilometer part. And I know how many meters are in a kilometer. There are 1,000 meters in a kilometer. So I'm going to put that conversion factor in, making sure that kilometers is on the bottom so that they cancel out. Okay, just like variables in math class. Like I have an X on the top and an X on the bottom. Now I'm in meters. So I'm going to stop with my length conversion because I'm in meters. I want to be in meters. So I'm going to stop there. Now I have to get hours into seconds. So I don't know how to exactly to go from hours directly to seconds, but you know what? I know how many minutes are in an hour. I know that there are 60 minutes in an hour. So I put that into my equation. Now here, hour is on the bottom, so I have to make sure that hour is on the top so those cancel. And then my 60 minutes goes on the bottom. But I'm in minutes. I have to be in seconds. Okay, I want to be in seconds. So I cannot stop there or I would have meters per minute and I want meters per second. So I stop and think and I'm like, okay, there are 60 seconds in a minute, right? 60 seconds in a minute. So I put in another conversion factor. This time my 1 minute goes on the top so that the minutes cancel, and I put my 60 seconds on the bottom. Okay, now I have meters, I have seconds. Now, guys, listen, be crossing out these labels. If you don't cross out the labels, you're not going to know when you end up where you need to be. Okay? You should go until you end up with the units that you need and they are not crossed out. So I'm in meters, I'm in seconds, I multiply across the top and divide by, I multiply across the bottom and I divide what I multiplied on the top by what I multiplied on the bottom, and I get 18 meters per second. Okay, now listen, this is a really important thing. We're going to do some more practice in class. We're going to apply this to a lab. This is an important thing you have to get because we are going to be using it all the time in class. Okay, this is super important to be able to convert. Now, if you're using the bridge notation, you would just put a line through these X's and it would be a straight division line across if that's what you want to do. Okay, you can do it that way. But this is dimensional analysis or bridge notation, and it's commonly used. It's the easiest way to convert because you can easily keep track of your units by crossing them out. That's an essential step. So on the side, somewhere, big letters, capitals, make sure you write cross out units. Okay, cross out units. because if you don't cross them out, you're not going to know if you've got to where you need to be. So our objective for today was to convert between metric units. Don't forget your 5 questions, and after we do some practice in class, you'll have a quiz.